All right, I'm gonna try this out. I've got two numbers here. I've got 65 million years, how many centimeters is that? And I've got 48 years, how many centimeters is that? I'm gonna use this cancellation units process. Remember that number. I highly recommend you write this stuff down too while I'm doing it. I'll try and go slow. The reason why I want you to write it down is so that you can develop muscle memory. It's just like playing the guitar or playing the piano. One of the things when you practice guitar or whatever it is, you develop muscle memory so that your fingers learn what to do. It takes time for that to happen. Same thing with this type of problem solving. If you're working on developing muscle memory and you go through the process and your body physically learns how to do it. Yeah, part of it is your brain, but the other part is the physical learning. It's called kinesthetic learning. So I highly recommend you follow along at home, and I'll try and go slow. So what I'm going to do with my first number, it's 65 million. That's when the dinosaurs went extinct. Just for practice, what I'm going to do is I'm going to take and convert this into scientific notation. So that's 3, 6, 7. This number is 6.5 times 10 to the 7th years ago. That's when the dinosaurs went extinct. They went extinct 6.5 times 10 to the 7th years ago. So what I'm doing, muscle memory style, I'm doing math with fractions. So what I'm going to do is I'm just going to take and I'm going to put this over 1, just so I can make a fraction out of it. The next thing I'm going to do is I'm going to multiply. And I'm going to multiply it by another fraction. I'm not doing one common mistake kids make, one common mistake that you guys make from some of the stuff that you learned in your math classes is you'll try and do this cross multiply and divide thing. I don't want you to do that. We're going to do math with fractions. So the next thing you do is you multiply. Well, what do I put in here? Well, what I'm going to do is I'm going to put in another fraction. And this is what I'm going to put in there. I'm going to take my scale, this information right here. This is the scale for my timeline. And again, like I said earlier, my timeline is 180 centimeters long, here to here. Your timeline, the length of your timeline is going to depend on how long your piece of paper is for you, whatever you select for this project. So now what I'm going to do is I need to get, I've got years on the top here. I'm trying to get an answer that's in centimeters, right? So that I can measure on my timeline. So in order for me to get rid of years and get a number that's in centimeters, I have to put 180 centimeters on the top. And I need to put 13.8 times 10 to the 9th years on the bottom. When you divide something by itself, you get 1, and that goes away. So when I do the math on this, it's 6.5 times 10 to the 7th times 180 divided by 13.8 times 10 to the 9th. So if you want to crunch that on your calculator, you would get 0.85 centimeters. Less than 1 centimeter. So what I would do over here, right? This is years ago, so this is actually centimeters ago. The dinosaurs went extinct. Yeah, time-wise, they went extinct 65 million years ago. But on my timeline, they went extinct a little less than 1 centimeter ago. And I would measure that out with my ruler. I'd measure out like I'd measure out 0.85 centimeters. And I would say dinosaurs went extinct. Right there. And that's how I would put that on my timeline for my dinosaurs. Do you want me to do the next one? Absolutely. Everyone's got their screens off, microphones off. I'm just trusting that you guys are following along at home. I'll talk you through this one again. This is the milestone I'm trying to convert. I'm trying to get dinosaurs go extinct on my timeline. They went extinct 65 million years ago, 6.5 times 10 to the 7th years ago. I use my scale to convert. My timeline is 180 centimeters long. That 180 centimeters represents the age of the universe, which is 13.8 times 10 to the 9th years. I have my problem set up right now. My years cancel out, my units, years over years, cancellation of units, they go away, and I get an answer that's in centimeters. So I take this number here, and I multiply it by that number there, and then I divide. And that's how I convert. I will save this video as well. I'm recording this right now, so I'm going to save this and it'll go up on my YouTube page. I'm going to do another one. I'm going to erase this. We'll do me. I am 48 years old. I was born 48 years ago. Where does that go on my timeline? Well, it's going to go over here somewhere for sure. Pretty close to now. Put that over 1 because I'm doing math with fractions. The next thing I'm going to do is I'm going to add in another fraction. I'm going to take my scale. It's the same scale from the previous problem. That doesn't change. I go 180 centimeters divided by 13.8 times 10 to the 9th years. Years cancels out. I get an answer that's in centimeters. And if you do the math on this one, you get 0.0000626 centimeters. This is another reason to use scientific notation. So I would move it 3, 6, 7 to there. 6.26 times 10 to the negative 7th centimeters. There's no way I can measure this out on my timeline. My life is 6/10 of the age of the universe. It's over here somewhere in this like microscopically close to the now, right? Me born. At this scale, it's ridiculously small that what I would have to measure up. It's 1/6 of my timeline. Excuse me. 6/10 of the timeline. I would have to live 62 million lifetimes to get to be the age of the universe. That's how that works out. I'll say that again. I would have to live 62 million lifetimes to live 13.8 billion years. That's basically what that's saying. That nuts? I'll stop recording now.